Hi, welcome back to the last part of chapter 5, which is the last part is about the backward method. Alright, so let me write down the last part title. So this is the last part part which is the backward method, which is in this part what we want to do is we want to find the value of our real variable value, which is value of x, whenever we are being given the probability value. So whenever we want to do this backward method, we are having 3 steps that we need to do, which is the first step that we need to do is we need to draw the standardized normal distribution with the probability area given to us. Alright, and then the second step that we need to do is we need to determine whether our z-score is on the left or the right side of our distribution, whether our z-score is negative value or whether it is positive value. And then we can identify the value of our x, which is we need to substitute the value of z, value of mu, value of sigma into the formula to identify the x value. Alright, so let us go into the example first, how we want to come up with the z value whenever we have probability value given to us. Alright, so let's say we have the first example given to us. So let's say we have this question, the probability of z less than a is equals to 0.67, which is, we know in this case 0.67 here is a probability value. Now we know that a here is a z value, which is a. We don't know what is the z value, and we already have the probability given to us. In this case, we know that backward method is, we know the probability value given to us. So from the probability, we want to know what is the z value, and then from the z value, then we want to identify what is the z value. So from the probability 0.67 given to us, so then we want to know what is the z value, what is the a value for that 0.67. Okay, so again 0.67 is the probability value. So again, in the S&D table, probability, we need to refer into the inside the table. So again, first step, we need to draw our distribution, our standardized normal distribution. Alright, so to draw our standardized normal distribution, so we know that our standardized normal distribution having the mean of 0. So we know that standardized having mean of 0. So we know that our A might be on the right side of 0 or might be on the left side of 0. Depends on the probability value. Okay, now how we want to identify the A is on the right side or the A is on the left side? Okay, so this one depends on the symbol given to us, less than or greater than. So if the symbol given to us is less than, we are going to start our shaded area from the left side of our S&D distribution. If the symbol given to us is greater than, we are going to start our shaded area from the right side of our distribution. Okay, so if we can see that our symbol given to us is less than, so meaning that we are going to start our shaded area from the left side of our distribution. Okay, and then look on our probability value. It's 0.67. 0.67 means that it is more than 0.5. When it is more than 0.5, means that it will exceed the middle line of our distribution. Meaning that from the left side of the distribution, then our shaded area will exceed the middle line, meaning that it will go up to the middle line, so might be around here. So our A will be here. So this is our shaded area for 0.67, because shaded area always represent probability. So this one is 0.67, more than 0.5. Alright, okay, so again, now we already do the first step and the second step. Then we can already identify our A value. So if we compare the shaded area with our shaded area in the table, it is the same shaded area. So then we can look the probability inside the table. So 0.67 is the probability value. Again, probability, look inside the table. Do not look outside the table. Do not look on the outside the table, which is 0.6 on the first column, 7 on the first row. No, that one is for the Z score. 0.67 is the probability. So look inside the table. So inside the table, 0.67, if you notice, let us make it bigger, the table. Okay, so 0.67 is here. This is 0.67. So this is a probability inside the table. So now our purpose is we want to know for this probability, what is the Z score? So again, Z score is outside the table. So for this probability, the Z score is 0.44. So for this probability, our Z score is 0.44, which is I'm looking for this one and this one. So the Z score is 0.44, meaning that our A value here is 0.44. So now we know for probability of Z less than 0.44, then we will have the probability 0.67. So that's how you find the value of Z. So then when you want to find the value of X, then you can substitute the value of Z into your formula. Alright, so let us go into the second example. So the second example is the same value of probability, but if you notice that our symbol is different, which is now our symbol is greater than. So again, the same thing, whenever we are doing for the backward method, we are being given the probability value. We want to find the Z value. We are moving backward. So first thing that we need to do is, we need to draw our standardized normal distribution with the shaded area for the probability value given to us. Alright, so first we draw our standardized normal distribution. So the standardized normal distribution with the mean of 0. Okay, so again, we want to draw the shaded area. So the shaded area for our probability, which is 0.67. So again, 0.67 is more than 0.5. So it's going to exceed the middle line. So again, we are going to start our 0.67, the shaded area, from the right side of the distribution, because the symbol given to us was greater than. So greater than, we are going to start from the right side of the distribution. So we start from the right side, and it will exceed the middle line. So from the right side, exceed the middle line. So it will exceed the middle line. So meaning that maybe around here. That means that exceed 0.5. Okay. Alright. So we know it will exceed the middle line. So our A will be here. Okay. And we know that it says that greater than 8. So that's why our shaded area for the probability 0.67 is this one, more than the 8. So this shaded area represents 0.67. And again, we know that this A is on the left side of 0. So meaning that later our A value is going to be negative value of Z score. Alright, so this one is going to be negative Z. Alright, okay, so again, this one is negative Z. We don't have any negative Z value in our table. So when we have negative Z, we need to flip our distribution into the positive side. So when we flip into the positive side, so we are going to have our distribution on the right side of Z. But now the shaded area is less than the Z value, which is this shaded area is still 0.67 probability. Alright, so again, because just now we already know for the probability 0.67, the Z score is 0.44. Okay, since that our original Z score is on the negative side, so our original Z value or our original A value, the A is negative value, so means that our Z value is negative 0.44. So meaning that for our answer, the answer is going to be the probability of Z greater than negative 0.44. We are going to have probability is 0.67. Alright, so let us go with the last example, which is probability of Z less than A equals to 0.75. So still the same thing. We need to draw, first step, we need to draw the standardized normal distribution with the shaded area. So we draw our standardized normal distribution. So again, we want to know, we start from the left or the right. Look for the symbol. If it says that less than, we start from the left. If it says that greater than, we start from the right. And if our probability is more than 0.5, it will exceed the middle line. If our probability is less than 0.5, it will not exceed the middle line. Okay, so since that 0.75 is more than 0.5, so it will exceed the middle line. So we start, since that the symbol is less than, we start from the left, and the probability is 0.75. It is more than 0.5, it will exceed the middle line. So our value of A is going to be here. So this is A. So this is our shaded area. And this is 0.75. Okay, so again, to know for the Z value or the A value, since that this shaded area, if we compare with our table shaded area, they are the same. So let us pull out the table. Okay, now again 0.75 is the probability value. What we want to find is the Z score. So again, for 0.75, do not look outside the table. Alright, we need to look inside the table. So don't look for the 0.7 on the first column, 5 on the first row. That is for the Z score. 0.75 is not Z score. 0.75 is probability. So look inside the table for 0.75. So we look for 0.75. If we notice that we don't have exactly 0.75. If we notice that 0.75 is in the middle here. It's in the middle, 0.7486 with 0.7517. It's in the middle. We don't have exactly 0.75. So if we don't have exactly 0.75, it's in the middle of two values. Always take the value of probability, the lower probability. So, meaning that what we are going to take is this probability, 0.7486. Alright, so for this 0.7486, so the z-score going to be 0.67, which is this one, 0.67. Okay, so for the z-score 0.67, the probability is 0.7486. Okay, but we don't want 0.7486. We want 0.75. So, we take the difference between 0.75 with 0.7486. Difference means that we need to minus 0.75 minus 0.7486. So when we minus, we will come up with 0.0014. So the difference, the meaning value of the difference is 14. Okay, so the 14, we look into the add column on the same row with 0.6. So we look on the same row of 0.6. So we look in the add column, look for the value of 14. But if we notice that we don't have any value of 14. So if we don't have any value of 14, we take the value that is the nearest with 14. So the value that is nearest to 14 is 13. Okay, so again, 13. What we want to have is the z-score. So z-score is outside the table. So for the 13, the z-score is 4. So this 4, we add at the back of our z-score. So the 4 value, so we have here 0.674. That is for the probability of 0.75. So meaning that for our final answer, probability of z less than 0.674, then we will have the probability of 0.75. So that is our answer for this example. Alright, okay. So let us have a look at one example in terms of the real situation, in terms of the context with the real variable value. Okay, so for this example, it says that the length of components produced by a company are approximated by a normal distribution model with mean of 4 cm and a standard deviation of 0.05 cm. If a component is chosen at random, find the value of K if 5% of the components are more than K cm. Okay, so if we can see that inside this question, it is already mentioned to us that the variable that we are studying is the length of the component. So, length is the continuous variable. And it says that this length is approximated by normal distribution. So again, length is continuous variable and normal distribution, again, it is about the continuous variable. Okay, and it is given to us is the mean value. So the mean value is 4 cm. Now we have our first information, which is population mean, which is the mu. So the mu is 4 cm, which is 4. And then we have the standard deviation. So standard deviation is the population standard deviation, which is sigma, which is given to us is 0.05. So 0.05 cm. Because whatever normally distributed value given to us is represented the population. Alright, okay. And it says that if a component is chosen at random, find the value of K if 5% of the components are more than K cm. So, we already been given 5%. Percent is in terms of probability. So now we have percentage given to us. We have probability given to us. So now we have percentage. Percentage is probability. So what we want to find is find the kcm. Cm is in terms of the length. So what we want to find is the value of our variable. So value of our variable means that we want to find the x. So we are having P, we want to find X. So when we have P, we want to find X, means that this one we are doing for the backward method. Alright, okay, so what we are having here is, it says that find the 5% of the components are more than kcm. So means that probability of the X more than k, then the probability is 5% is 0.05. So this is what we want to find. Alright, okay, so now the same thing. So what we want to have here is the probability of X greater than k equals to 0.05. Okay, so again, we know that from X, we need to transfer into Z, right? So the same thing, we need to substitute into the formula. So when we transfer into Z, we are going to put into Z. So when we put into the formula, our X value is a K, isn't it? So we are substituting the X with the K minus with the mu, which is our mu is 4. So minus with 4. Divide with the sigma, which is again the sigma is 0.05. So 0.05. So the value is equals to 0.05. Alright. So let's say we consider the whole thing here as A. So we are having this one as Z greater than A equals to 0.05. Okay, so the same thing, when we want to know, when we are having probability, we want to know the Z value, we need first to draw the standardized normal distribution. So we draw our standardized normal distribution. Then we need to have our shaded area. So we need to know, we start our shaded area from the left or the right. We need to know the symbol. So symbol shows greater, so we start from the right. And we look to our probability value. If it's more than 0.5, it will exceed the middle line. If it's less than 0.5, it will not exceed the middle line. So our probability is 0.05. It is less than 0.5. In fact, it is lesser than 0.5, so means that it will not exceed the middle line. It will not even reach the middle line. So means that we are going to start from the right and will not exceed, will not reach the middle line. So meaning that we maybe just up to here. So this is our A value and this is our 0.05. Okay. So again, we know that this shaded area, if we compare with our table shaded area, it is not the same. So again, what we are going to use is, we are going to use the white area. So the white area, we need to have is 1 minus 0.05. So then we can use the white area using the SND table. So 1 minus 0.05, you are going to have 0.95. So then 0.95, look inside the table, to come up with the Z score. Okay, so we still use the same method. Look inside the table for 0.95, then look for outside the table for the Z score. Okay, so since that okay, so we know that for the white area in our distribution 0.95, so we look inside the table. So 0.95 if you notice that we don't have exactly 0.95. What we have is in the middle 0.9495 with 0.9505. So again, we take the lower probability, which is we are going to take 9495 with the z-score 1.64. And again, we don't want 9495, what we want is 95. So take the difference. So we will have the difference value is 5. So for the 5, look inside the add column. So the add column, you can see that we have the value of 5. So for the z-score, we can see that we have the value of 5 here. So meaning that our z-score is going to be 1.645. So that is the A value, 1.645. Now we know the A value is 1.645. Then we can substitute into the A value to find the K. So we know that A is 1.645 and A is equals to K minus, K minus 4 divide with 0.05. So what we want to know is K. So we move 0.05 to the other side. So 1.645 equals to K minus 4 divide with 0.05. We want to know the K. So K is equals to 1.645 multiply with 0.05 plus 4. So then we can calculate for the value 1.645 multiply 0.05 plus with 4. So we will come up with 4.08225. 4.08225 cm.